This is Science Quest. With your host, Jed Allen Friels. He's taking you around the world, discussing everything science.
Hey, I'm Jed Allen Friels, and thanks for joining us today on Science Quest for another episode aboard the Lake Guardian. Today we're taking water samples using the Rosette. It's like a hydro lab on steroids, and we're bringing it in right now. We've collected water samples all the way down through there, and we're going to take a look at what we've got.
So we just employed the Rosette, which takes 12 bottle samples. We are at site 3C, I believe. Is that correct? 3C? 3B, I'm sorry. Rosette will go down, collect water samples at the bottom. They will cap shut, bring those back up so we have the samples at each levels that we want. We will then open those up, pour those into 4 bottles, and then we'll go back and analyze those.
Hey Max, I just saw we deployed the Rosette. What can you tell me? What are we seeing?
Well, if you want to take a look at this screen right here, we got a couple different things. Blue is our oxygen, red is our temperature, yellow is our beam attenuation, which is basically the clarity of the water, and green is our phosphorus, or chlorophyll, I'm sorry, and our chlorophyll would be like the algae and plankton.
Got it.
So you can see here that the temperature is relatively high at the surface, and then all of a sudden it drastically falls. That's the thermocline right there, because denser water falls to the bottom, and heavier and colder water is denser, so it stays down there. Warmer water is less dense, it stays towards the top. So you have this thermocline plane, they call it there. You can see colder water also holds more oxygen. So you can see as the water gets colder, the oxygen goes up. Also down here you can see this hump right here in the fluorescence. That is our deep chlorophyll layer, and that is where a lot of the phytoplankton and zooplankton are hanging out right now.
What's our depth right there now, Max?
My depth right now is I am in 89 feet of water, or sorry, 89 meters of water, so that's about 291 feet.
And our chlorophyll level is up around the 45 to 50 meter level right now.
That is correct.
So when we come back up later, we'll drop our nets and maybe do some plankton nets on the way up at that particular level.
We will bring them down to 60, so that way when we bring them up, it will capture that layer. Right now I'm firing the bottles down at the bottom for one of our science groups, and I just press that button. That shuts the bottle, and there will be our B- water.
So you're pressed, and we've just collected how many vials on the Rosette?
This will be number 6.
Number 6. You fire the bottles individually on the Rosette, Max?
That is correct, yep. So now I have my water from the bottom, so I have my winch control here, and I'm going to bring it all the way up to the surface because another science group would like surface water. So I'll bring it up to the top, fire the rest of my bottles, and call it a day.
Are we firing at the thermocline at all right now?
No, we're not firing at the thermocline.
The only thing we're using that reading for is so that we can run the next test, our plankton nets, and drop to that level. So we're recording our data even though we're not making a collection there.
That's correct.
Max, fantastic, thanks. I'm going to head back downstairs, try to catch a Rosette when she breaks through the water.
You know, just hit.
So the
Which one didn't pop there?
Hey Max, while we're taking water samples, would you mind explaining some of the other things that the Rosette can do while it's taking water samples?
Sure. So here we have our fluor probe, and this uses lasers to measure the chlorophyll in the water. So
Laser technology, tell me a little bit about how that works.
Well, it shoots the water flows through here, and it shoots a laser through the algae as it goes through, and different algae fluoresce at different rates and different colors and stuff, so you can tell which kind of algae is going through there and what kind of algae is in the water. We also have this here. This is a light sensor, so it tells you how far the light penetrates through the water, so it can also give you an idea of how turbid the water is. And down here, we got a couple of different things. This is our nitrate sensor that also uses laser technology. This here is an altimeter that sends out a sonar ping to let me know how far off the bottom I am, because I don't really want to run this expensive machine into the bottom.
Yeah, I hate to bury it in the mud.
That's right. Then here is another oxygen sensor that uses a like jelly sort of membrane, but the water passes over it, and it tells how much oxygen is in the water for milligrams per liter. And then here we also have sort of the same thing. The water, there's a pump attached to this, so this sucks in water, and it tells us the temperature, dissolved oxygen, and the conductivity. And the conductivity is basically how much particles are in the water, so that gives us an idea of how turbid the water is.
So these measurements are being constantly taken across the Great Lakes, not only Lake Michigan, but on other lakes when you guys are there too.
Yep, we do all the Great Lakes twice a year, and each year we do a lake of focus, and this year happens to be Michigan.
How many different testing sites are there? Give me a rough estimate on all 5 Great Lakes.
That's a tough one. I can show you the maps if you'd like later, and you can take a picture of them.
That'd be
but
great.
I would say that there's probably about 40 per lake, so...
We're
yeah.
talking hundreds.
Yeah.
It's amazing. We're constantly monitoring the health of the Great Lakes. Max, thanks so much for explaining that to us today.
No problem.
So today we learned just a little bit more about water quality in the Great Lakes. And one of the tools, the Rosette, is like a hydro lab on steroids, and what it can do to help us monitor the Great Lakes and its water quality. I'm Jed Allen Friels, and thanks for joining us on another episode of Science Quest aboard the Lake Guardian this week.
This is Science Quest. With your host, Jed Allen Friels. He's taking you around the world, discussing everything